In this section, we're going to talk about some applications of linear equations, and I don't have a lot here. I think I've got 3 problems here, but it'll give you an idea of how linear equations can be utilized. One of the common applications of a linear equation is when you have something that's called straight line depreciation. That's when an item or an automobile or a piece of equipment depreciates at a linear rate for a period of time. So let's take a look at an example here. Suppose an automobile depreciates linearly for a period of 10 years. The original value was $20,000, and after 5 years the auto is worth $16,500. Let V be its value and T the number of years that have elapsed. So what I'm asking you to do here is, first of all, write a linear equation that represents the value of the auto in terms of the years, and then we're going to find the value of the car after 9 years. Okay, so what we can do here is, first of all, we know that initially, that would be when t equals 0 years, that the value, or V, of the car is $20,000. And then we're given 5 years later, so when t equals 5, we know the value of the car has decreased to $16,500. Well, basically that gives me 2 points to work with. I know one point would be when t is 0, V is 20,000, and the other point is when t is 5, V is 16,500. So consider those 2 points. I can find the slope of this relationship. So I'll treat the V's like I would the Y's, and I'm going to treat the T's like I would the X's. So take the second V value, 16,500, subtract the first V value, 20,000, and that's going to give me negative 3,500 here. And then for the T's, take the second T value, which is 5, and subtract the first T value, which is 0, and it's going to give me 5 minus 0, which is 5. So now that's going to give me the slope of negative 3,500 divided by 5, which is negative 700. So I know the slope of the line is negative 700. Now, one other thing I want you to remember here, remember when the X value is 0, the corresponding Y value is the y-intercept, or the B value in our formula. Well, here we know that when t is 0, the value is 20,000. So this 20,000 is like the B in the formula, because this is like the y-intercept. And now technically it's the v-intercept, but it is like the y-intercept. So now we know the slope is negative 700, and we know that B is 20,000. And if you think of the equation in the form of y equals mx plus b, the only difference here is we're not using x and y, we're using v and t. So actually our formula would be v equals mt plus b. So in that case, since m is negative 700 and b is 20,000, our formula would be v equals negative 700t plus 20,000. And so that's the equation. And then to answer part B, we just plug t equal 9 into the equation. And so if you plug 9 in here, you get the value is negative 700 times 9 plus 20,000. And then that's going to be negative 6,300 plus 20,000, which is 13,700. So that's the value after 9 years. Now the second one, you probably are aware that when you have a service person come over to service your plumbing or your air conditioning or your heating or something, or electricity, or whatever the case may be, generally they're going to charge a fee just for showing up. So here the plumber charges a $75 fee for just showing up, and then he's going to charge an additional $27.50 for every hour that he works there. So the first thing we want to do is we want to write a linear equation that gives the total charge, so we'll call that C, by the plumber based on the number of hours. And then we want to find the total charge for 3.5 hours. Well, this actually is much easier than it looks. If we let H represent the number of hours the plumber works, then the total cost, we'll call it C, would be it would be $27.50 or $27.5 per hour, so 27.5 times H, where H is the number of hours, and then plus the flat fee of $75. So that would be the equation. And that is a linear equation. It's just that instead of Y we're using C and instead of X we're using H, but it is a linear relationship. And then here the second question says find the total charge for 3.5 hours. So all we do there is let H equal 3.5 here in this formula, so put 3.5 in for H and you get 27.5 times 3.5 plus $75. And when I put that in the calculator, I got $171.25. Okay, now the next problem says DVD discs are sold for $12.50 per dozen. A small company has a weekly cost of $5,000. So that just means regardless of how many they manufacture and sell, it's going to cost them $5,000. But then it's going to cost them $5 per dozen of DVDs they manufacture. So the question says write an equation that represents the company's weekly profit based on the number of dozen of DVDs sold. That'll be X. So we're going to let X represent the number of dozens of DVDs. Now, profit is revenue minus cost. So you may not have known that, but now you do. Your profit is always the revenue, the amount of money you take in, minus your cost. So what I need to do is I need to find the revenue. Well, the revenue is based only on the number of dozens of DVDs that we sell. So if I sell X dozen DVDs and I'm going to get $12.50 per dozen, then the revenue would be 12.5X. Now to get cost, remember here I have a flat cost of $5,000. That's called a fixed cost. And then I have a variable cost of $5 per dozen. So the cost would be $5 per dozen. So that would be 5X. So the total cost would be the $5,000 plus $5 per dozen, or 5,000 plus 5X. Now back to this. Profit is revenue minus cost. So now that I have the revenue function 12.5x and the cost function 5,000 plus 5x, I can subtract the cost from the revenue, and remember the minus here has to be distributed. So I have 12.5x minus 5x, so 12.5x minus 5x is 7.5x, and then I also have minus 5,000. So that's minus 5,000. So the profit is 7.5x minus 5,000. So that's your profit equation. Now, in order to break even, you break even when your profit is 0. You also can think of it as when revenue equals cost, but still you break even when your profit is 0. So because in the beginning you're losing money, so you're not making a profit in the beginning, but once you reach a certain point in manufacturing, your profit reaches 0, and then anything beyond that you'll get a profit of greater than 0. So I want to find when the profit is 0. So I'm going to set this profit function equal to 0 and solve for x. So to solve this for x, add 5,000 to both sides, so I get 7.5x equals 5,000. And then when I divided both sides by 7.5, I got x equals 666 2/3. So, but since I can't make a portion of a dozen, I don't believe. I think I need a whole number here. So I'm going to go ahead and bump it up to 667 dozen. So at 667 dozen, I would break even, and anything above that, I would actually have a profit. Okay, so that ends this series of videos on linear equations, and so hope you enjoyed them.